So now we've created a new class. We've attached it to the splatter decal particles system that we created in Unity. And we are going to add we can get rid of update because we're not going to use it. And we're going to add a new function called setParticleData. And setParticleData is going to take a particle collision event as a parameter that we're going to call, you guessed it, particle collision event. Now, I'm going to add a little bit of pseudocode in the form of a comment here because in this function we are going to record collision, position, rotation, size, and color. But I want to set up a little sort of scaffolding around it before I get to recording that data. So we're going to take in the particle collision event. We're going to store the data from it, right? And what we want to do is we want to create an array of our particle decal data classes to store that information in. So in order to work with that array, we are going to need an index, right? We're going to need to be going through that array. We don't want to just loop through it continuously. We want to set the data, advance to the next one. And so what we're going to do is we are going to add a private int, which is going to be called particle decal data index. Because what we want to do is we want to go through the array, set each index, and then once we've reached the maximum size of our array, we're going to start with it at, let's say, 100, just to make it easy to see. Then we're going to loop back to the beginning and overwrite the older data so that we can just keep using the same array and again. We never have to create a new array. We're not going to allocate, and it should be pretty performant. So we're just going to be looping over the same array and overwriting the old data with new data once we run out of space. And so what we're going to do is we are going to check if particle decal data index is greater than the maximum number of particles. So we're going to need a variable for that as well. So we're going to add a public int that we're going to call max decals, and we'll set that to equal 100, which is kind of a low number to start, but we can add to it later. So we're going to check if the decal data index is greater than or equal to max decals. Then we're going to set particle decal data index to equal 0. So we're going to check if we've exceeded our max decals and then reset to go back to the beginning of the array. And after we're done recording all our data, then we are going to increment particle decal data index. So we're going to say particle decal data index plus plus. I figure better to have long descriptive variable names, right, than a lot of abbreviations. So now we are ready to set up our array to actually pass the data into. So we are going to create a private particle decal data array called particle data. And we're going to set particle data to equal a new particle decal data array with a size of max decals, and then we need to loop over it and add new instances of our particle decal data class. So we're going to say particle data I equals new particle decal data. Okay. So now we have a collection of particle decal data classes in their default state. So to fill each entry with data, we want to add some code to set particle data. So the first thing we're going to do is we're going to set the position of our particle based on the collision intersection, based on the collision of the particle collision event. So we are going to delete our comment now, and we are going to say particle data index, right? So we'll start off at 0. So the 0th index in particle data dot position, right? And this is the position field in our particle data class, equals particle collision event dot intersection, right? So we're going to set the position of our first particle in the array to the position of our first particle collision event intersection. Next, we want to determine the rotation of the particle and store it. So because our particles are not billboards, we need to manage their rotation in 3D, right? So if we just look quickly at the docs for the particle class, we can see the particle system.particle.rotation 3D is a vector 3. So this is the particle's rotation in degrees on each axis. So what we're going to need to do is do a little bit of conversion to get the vector 3, the Euler angle rotation from the normal. So what we're going to do is we are going to make a vector 3 variable called particle rotation Euler, and that's going to be equal to, again, quaternion dot look rotation, but this time we're going to pass in particle collision event dot normal, and we're going to convert it to Euler angles. Okay, so now, just for fun, because we want our splats to be a little irregular, we're going to further massage the rotation by randomizing it around the z-axis. So the decals are always going to be stuck correctly to the wall and angled to the wall, but they'll be rotated randomly against the wall to add some visual interest. So we're going to say particle rotation Euler.z is equal to a random range between 0 and 360. All right, so now we need to store that. So I'm just going to grab this dot rotation is equal to particle rotation Euler. Okay. Now we're going to do a similar randomizing process for the size so that we can have a little more irregularity, right? Because it's a splatter effect. We don't want them to be all exactly the same. So we're going to add a couple of public fields to add the maximum or the minimum and maximum random size. So we're going to add a public float called decal size min, and let's set that to 0.5, and we're going to add a public float called decal size max, and that's going to be equal to 1.5. Now, again, I'm just going to copy and paste this, and we're going to set the size field to equal random.range, decal size min, and decal size max, right? So that's going to generate a random float between the minimum and the maximum size we specify in the inspector and store that at that index in our particle decal data array. Last but not least, we want to set the color. A random color. So we are going to, in set particle data, we're going to add an argument of the type gradient, add a parameter of the type gradient called color gradient. And here, similar to what we've done, just going to paste that in again, dot color, the color of this entry in our array is going to be equal to color gradient dot evaluate random dot range 0 f 1 f. Make sure you get the f's, otherwise you get a random integer, which will just be 0 or 1. And so we're going to get a random color from our gradient and store it in our array. Okay, so at this point, we have stored position and rotation data from the particle collision event, generated size and color from our script, and put all of that into an array, right? Or we will do that once the function actually gets called. The next step is going to be to display the particles based on this data.